Hey guys, this is a page for our multi-strategy psychological signal processing for intensive care using registration project. So basically, cardiovascular diseases have been a leading cause of death globally, and this has been due to the fact that it has claimed 80 million people per year. So with this, due to the problems being experienced with the current local ECG screens are inefficient. So this project addresses the challenge of improving the diagnosis of cardiovascular diseases through the ECG analysis. So the traditional ECG methods were struggling with interpatient variability and data heterogeneity. Thus, they could fail to detect subtle patterns indicative of life-threatening conditions like hypemia and heart failure. So we shall use a computationally intensive and interpretable model to solve these problems. So basically, our objectives are: one, we are going to integrate psychological insights such as stress and anxiety into health monitoring. Yeah, through using the ECG signal results and integrate them with our model so that we can monitor one's psychological state. We're gonna also optimize intensive care environments so that in case of anything that may happen to a patient due to improper arrhythmia, so there should be a quick response by the medical personnel. We are also going to ensure scalability and adaptability, so it will be adaptable to many areas and environments. Basically, we're going to develop a solution overview. We're going to develop a deep learning model using convolutional neural networks with attention mechanisms, and it's going to be trained on ECG signals, that is the MLII and the V5. This will enhance noise solution. So the innovation will lie in integrating an attention-based CNN that dynamically prioritizes critical ECG features. Basically, we are going to use the AMIT VIH arrhythmia database that has footage annotated ECG recordings. And here the data was pre-processed with bandpass filtering of 0.5 to 40 Hz and normalization, which was improving the CNR for 15.2 dB to 28.7 dB. Key visualization included raw versus the filtered signals and the correlations. So the data set is balanced of a normal and abnormal bits, that support robust model training. So the methodology, basically, one, we're gonna do data acquisition. We get the data set, that will be the MIT VIH arrhythmia data set. Another, we're gonna do pre-processing where we shall remove the noise from the data. We do baseline correction and normalization of data. Thus, we shall improve signal quality. The other will be model deployment. We're gonna model development. We train a high capacity model, and we distill knowledge in the lightweight model. So this is our system architecture, starting from the data collection, then to the setup, the development of our project, then we deploy the project. So, so far, let me take you through knowledge dissertation. Here we shall transfer knowledge from a large model, small efficient one, and this will maintain accuracy. So, and it will be ideal for wearable devices. Therefore, in our project, we're gonna include psychological signal processing, and this will work on state and anxiety. We'll show the impact of anxiety and stress on cardiovascular health. This, in most cases, leads to death, so we must be keen when developing the model. So this is a short demo of our project. As you see, that is a demo. SIGI state detection. Basically, we shall have the impact and relevance of the project. It's gonna save lives. So the AI-powered ECG signal will take Uganda's critical shortage of cardiographers and helping detecting arrhythmia earlier. It advances for SDGs and aligns with SDG 3 and so on. So it will empower key users and it will benefit clinics and it will be affordable. It will be a scalable model. So and it is a good one. It is made in Africa. So it will be easily accessible to local ones. Intellectual property, the core intellectual assets, we have a novel hybrid CNN, LSTM ECG model, and age-optimized knowledge distillation and HRV stress fusion algorithm that are patentable due to unique African adaptations. Basically, our protection strategy will be like we shall use patents, the trade secrets, and the copyright. So as we limit illegal use of our idea. The key advantage it combines clinical efficiency, that is accuracy, and it's easy deployability. That means it creates a defensive technique for LMI. Monetization. Here we have a commercialization of the strategy. We are targeting 500 plus clinics in rural areas and 10 regional hospitals. So in Africa, income-wise, it will be 988 billion for cardiac monitoring market, and in global LMICs, it will be 1.2 billion people lacking cardiac care access. So our revenue streams will be the device through the lending the model, device lease, that is 75,000 per month, the paper scan 1,700 per test, and cloud API through that API. So we also have our partners there. One will be the Ministry of Health, Uganda, the MTN or Airtel mobile payment integration, which we shall include, and the LMIC scaling. So in our future, we are willing to enhance the ECG analysis by integrating multimodal data such as phototherapy, for signals and patient history. And also scaling opportunities in our model will include geographic expansion into East Africa and South Asia, as well as extending to maternal health and chronic disease screening. So that's all for our pitch. In conclusion, our model will be highly accurate and it will be 10 times the cost will be reduced 10 times than the current local methods, and it will impact more, especially the local people. So on.